Hi guys, our topic for today is let's talk about equilibrium. What is equilibrium? Equilibrium is the condition of a system when neither its state of motion nor its internal energy state tends to change with time. A simple mechanical body is said to be in equilibrium if it experiences neither linear acceleration nor angular acceleration, unless it is disturbed by an outside force. It will continue in that condition indefinitely. So, ayun po yan guys. I have a example to solve this problem. Um, Babasahin ko po muna bago ko po ituro sa inyo kung paano po siya i-solve. A block of weight is suspended from a rope tied to two other ropes at point O. One rope is horizontally attached to a wall and the other is fastened to the ceiling. The angle between ceiling and the rope is 60 degrees. What are the tensions in each of the ropes? Assume the weights of the ropes and the knot are negligible. If the weight of the block is 100 N, what is the tension in the ceiling rope? So guys, this is illustration shows the arrangement described in the problem. Ito po. So mapapansin nyo po, ito po yung T1. Then, ito po yung T2. Nasa negative X po siya. Then T3 is to the negative Y po, sa may baba po. There is another system to consider. The connection between the T3 rope and the block. This system is useful because it relates the weight of the block to the tension in the rope. This in turn will relate the weight of the block to the tensions in the other two ropes. First, draw force diagrams for the two systems. Ito po. The coordinate system shows horizontal to be along the x-axis. Ito po ang x-axis niya. Patagilid. Sa gilid. And the vertical to the follow y-axis. Ito po. Notice T3 and W are the only two forces acting to the block. This is because these are the only two forces actually connected to the block. Let's start with this system. Group the forces by the coordinate system. In the x-axis direction, ayun po, there are no forces acting on the block. So, the Fy is equals to 0. For the y direction, T3 is pulling the block up in the positive direction, while the weight pulls the block down in the negative direction. Since the block is stationary, the total of these two forces is equal to 0. Ito na po siya. Ayan po. Sana maintindihan nyo. Since both of these equations are equal to the same thing, they must be equal to each other. 0 is equals to T3 minus W. T3 minus W. Or pwede naman po siya sa T3 is equals to W. Now, we have the tension in the first of our ropes. Now, let's find the tensions in the other two ropes. Note in the illustration how the sailing rope's force is broken into its horizontal and vertical components. This will make it easier to add up our forces along our coordinate system. First, look at the forces along the vertical axis. The vertical component of T1 is pulling the knot of the positive Y. This po. Positive Y. Nasa taas po siya. While T3 is pulling the knot down in the negative Y direction. Sa baba po. The vertical component of T1 is T1 sine 60 degrees. So, Fy is equals to T1 sine 60 degrees plus negative T3. Again, the nut is stationary and is in equilibrium, so the sum of the forces equals 0. 0 is equals to T1 sine 60 degrees minus T3. Pwede naman po siyang T3 is equals to T1 sine 60 degrees. We know T3 is equals to W from earlier. This equation becomes W is equals to T1 sine 60 degrees. Using sine 60 degrees is equals to 0.866. And W is equals to 0.866 times T1. And then when you solve this, T1 is equals to 1.155 W. 2 tensions down and the one, ganito po siya. Malabo po kasi yung camera. Pasensya na po. 2 tensions down and 1 to go for the final tension. Look at the forces acting along the horizontal axis. The T1 horizontal components is pulling the nut in the positive x direction while T2 is pulling in the negative x direction. Sa negative part po siya ng x. The horizontal component of T1 is T1 cos 60 degrees. Ito po siya. F x T1 cos 60 degrees plus negative T2. This. Since the nut is stationary, the nut is equilibrium, and f of x is equals to 0. 0 is equals to T1 cos 60 degrees minus T2. Or, pwede naman po siyang T2 is equals to T1 cos 60 degrees. We know from above that T1 is equals to 1.155 times weight. Plug this into the equation for T1. T2 is equals to 1.155 times weight cos 60 degrees. From our calculator, we know cos 60 degrees is 0.5. So T2 is equals to 1.155 times weight times 0.5. And T2 is equals to 0.577 weight. Now, we know all the tensions in the ropes. The second part of the problem gave a value of W equal to 100 N. Substitute this value into the tensions to get T1 is equals to 115.5 N and T2 is equals to 57.7 N and T3 is equals to 100 N. This. The problem is specifically as for the tension in the sailing rope. The sailing rope was the T1 rope and the T1 is equals to 115.5 N. The key to this type of problem is to isolate your system and locate all the forces acting on individual parts. Since the system is in equilibrium, the sum of all those forces will be equal to 0. That's all. Smile.